Hi, it's Jan Beta, and today I'm going to continue working on this Macintosh Performa 630 power supply that I found to have some leaky capacitors in it in the previous video in this series. As I found out in the previous video, this had several leaky, smaller electrolytic capacitors in here. And actually these series of Macintosh computers pretty much all have issues with their power supplies these days because these don't age very well. Some people in forums I read claim that these are not well designed or underpowered. I don't really think that's the case looking at this. But I'm not sure. I'm not an expert on power supplies. As a matter of fact, the electrolytic capacitors, particularly these smaller ones here that are close to components that run warm in regular use, they do leak, and when they fail, they might explode in violent ways. I've seen pictures in forums that people posted, and basically they destroy the whole power supply because they go so violently. And I think I caught this one right on time. I already replaced some of the leakier things and I scraped away some of the solder mask where the electrolyte actually had eaten into the solder mask. I'm going to replace the remaining capacitors that I didn't have in stock with fresh Panasonic brand good capacitors. This whole bulk here that's hot glued together, it seems we're going to have to do some operations there to get these out. And then at the end of this video, hopefully we're going to be able to test this and the machine boots up without any problems. Maybe. We're going to see. So in terms of this being a bad power supply, I don't really think so, as I said. I think what happens in these machines is that the thermal design of them is not very good. There's just a single fan in these cases, which Apple used for a number of machines actually. There's just one fan that cools the power supply as well as the main board and all the other components for that matter. That's pretty much the problem, I guess. If that gets dusty and doesn't have enough airflow and the cooling vents get kind of covered up by dust, this stuff is going to run pretty warm, and the power supply runs warm naturally under loads because there's a lot of switching going on transistors and the capacitors get warm. And if these get warm, the electrolyte gets warm and starts, in the worst case, they start drying up and finally sometimes short out and then explode and spit the remaining electrolyte over the whole circuit board, which then in turn eats into the traces and components and things like that. And it's very difficult to remove once that has happened because there's a lot of heat going on. You really have huge scorch marks on these boards. And a lot of the components that surround the exploded capacitors are pretty much gone. Usually, if that happens. And yeah, as I said, I caught this one in time. These definitely started leaking. I already replaced them. I'm going to replace all of them just to be on the safe side. And I think I ordered the correct ones. I'm not quite sure. The sizes of these are a bit of a problem because some of these are the taller variant with a smaller footprint. And I didn't have these in stock. So hopefully we can make these fit in there. And some of the values I'm going to use parts from my parts bin that I already had. Pretty long life Panasonic caps, regular capacitors, no low ESR stuff because I don't think it is necessary in a power supply from 1994 to use low ESR stuff. And in fact, you can sometimes make these oscillate in weird ways if you use too modern power supply caps because these usually used lower frequency switching than the current power supplies, and yeah, low ESR caps are just not a good idea because low ESR nowadays means a lot lower ESR than what it meant in 1994. So yeah, let's take a look at this and take the old capacitors out. I'm going to take pictures of this, and there's also a website that has all the capacitor values that I'm going to link again already did that for the last video. Yeah, I think that's pretty much all I want to say about this. If you have one of these machines, it's definitely a good idea to take this power supply out. I've shown how in the last video. It's not a big deal really, and chances are you are going to have leaky capacitors on that power supply PCB as well, just like I have here. This machine was actually booting up when I tried it, when I got it. It just didn't boot from the hard disk, but that might be due to the hard disk. So this power supply worked, although it had pretty badly leaky capacitors in there. So yeah, with that out of the way, let's jump in and try to replace all the capacitors on this, all the electrolytic capacitors, that is. The other ones usually have a much longer lifespan. So the worst part is going to be this conglomerate here. There's a coil that's glued to the capacitors, so we're going to have to do a lot of glue removal here. I think I'm just going to cut this glue off and try to remove as much of it as I possibly can. And then I'm going to do my usual move of replacing one capacitor at a time. Yeah, this is definitely hot glue that turned the color of orange for some reason. So yeah, this is going to be fun because this stuff is pretty sturdy. But these are all basically one lump, so we have to at least cut some of this. Yeah, this works reasonably well. These are all really loose. That's strange. No, the solder joints look all right, actually. Still, this is wiggling way too much for my taste. It was just held in with the hot glue there. So yeah, I'm just going to nibble my way here. Let's see. This other one here is also glued in, I believe. Usually you can use alcohol to dissolve the hot glue and make it easier to remove. So I'm going to spray some on there, I think, just for good measure, to see if that helps in any way. The capacitors are going to go to the trash anyway, so I'm not too worried about damaging them, which I already did. This looks like amber or something. Quite neat, actually. So, and there's another one here. Sadly enough, I'm going to add new hot glue once I'm finished, I guess. But yeah, I think I'd rather fire up the desoldering station and try to wiggle them all loose and then replace them one by one. I already marked every old capacitor with a red dot on the top, which is a good idea, just to be able to tell which ones I already replaced in an easier way. Let me take a couple of seconds to thank the sponsor for this video, PCBWay, my favorite manufacturer of prototype PCBs of all kinds. They also do CNC machining, 3D printing, sheet metal fabrication. They can populate your boards for you. Basically everything the tinkerer and more professional customer needs. The quality is absolutely outstanding, pricing is super reasonable, and delivery is quick. They also offer excellent service. I highly recommend checking out the link in the video description. Let's get back to our power supply. Oh, and another thing that I'm going to have to do is to replace these mains wires here, because I melted quite a bit of the insulation, as you can see. So I'm just going to cut these and put slightly longer wires on there. And these were soldered to this part here, the socket for the mains. I'm kind of eager to power this thing on because it is a nice machine, except for the couple of issues that it has. So this is now loose and should, in theory, somehow lift off the board. I'm just doing some more nibbling here. Yeah, it's like a weld bond to the circuit board here. Wow. This is just a single-sided circuit board, thankfully. So there's not too much we can destroy on this side, except for the components, obviously. That is just really nasty stuff. I think that might be enough to put a new capacitor in there. Yeah, I got it reasonably clean. That is kind of a standard 470 microfarad one. And there is actually a way, or at least one way, to replace this power supply with a PC power supply, with a modern power supply, because the voltages are the same. The problem is that you need a soft start mechanism that is not like the ATX soft start mechanism or electronic mechanism that we have these days. So you have to make a little adapter board with some logic chips to make that work. It is possible, and then you basically, the main problem is fitting it into this enclosure here. because this has one of the slide things that the mainboard sits in on its side. So everything must be aligned properly for the system to align properly, basically. That doesn't make things easier. I'd rather recap this than to try and build a PC power supply that is compatible with this machine. But maybe, if I fail fixing this, I'm going to get back to trying to build a modern power supply for this. We're going to see. This is a 16 volt one. The other one, the original, was a 10 volt one. They're the same form factor. Going slightly higher voltage doesn't make a difference usually functionally, and it even sometimes can make them live a bit longer. One thing you want to keep in mind is that in components that get warm, you want to use at least 105 degrees Celsius rated capacitors, and all the ones I have are. That is always a good idea because they last a lot longer, especially if they get warm. Okay, that's soldered in nicely. I'm just going to stop talking. There's a lot of capacitors in here, and most of them are not very interesting. So yeah, just going one by one, taking pictures of everything, and I try to put everything in the correct polarity, which is highly important, especially in a power supply. And of course you want to use the correct capacitance, microfarad rating. Is that also... Oh, that smells fishy. Fishy smell. It's always a sign of leaky capacitor. So that one might just have leaked as well. That's not good. This is the 1000 microfarad underneath the heatsink there. That is glued in and it smells like rotten fish, so that definitely leaked as well. So we're going to have to do some more cleaning. There's our foot of the capacitor that's still glued to the circuit board. The small one there I already replaced, and that was definitely leaky. That was visibly leaking, and I already removed and replaced that because I had that in my parts bin. This is going to be more work than I anticipated. Hopefully the other ones didn't leak as well. So this one, I think the 1000 microfarad capacitor probably didn't leak. The larger ones usually hold up better than the smaller ones, but the one next to it leaked, so this was compromised as well. This needs a bit more cleaning, I guess. I'm going to do this for every single one of them, and hopefully most of them haven't leaked. I got some new side cutters. These are awesome. Knipex, of course. These are the old ones, which lasted a long time, but now they are kind of dull, and I use them for removing hot glue. But I still keep them clean. They still cut wires as well. These are ESD safe as well, so I wanted these. There's a lot more repairs that we have to do, and fixing of the solder mask and things like that. Yeah, I'm just going to fast forward this. This is not very interesting. I'm going to report back when I have more of this done. That went rather smoothly, although I noticed that basically all the board, when heated up, smells a bit like fish. So there was definitely leakage going on there. I think I cleaned most of it off with IPA. I'm going to clean the backside of it more thoroughly even. And I'm going to replace this one as well. I bought this replacement which is, this is the mains filter cap, and usually these last a long time usually. This is the exact same rating, 400 volts, 390 microfarads. This is a 105 degrees Celsius rated one that I bought here, Nippon Chemicon, good brand, and this is a Nichicon that's only rated for 85 volts, 85 degrees Celsius. The only problem is this is one of those modern snap-in capacitors. It should have the correct pin spacing, but not quite sure if this fits the footprint. And this is also glued down, so this is going to be fun to get out there. Yeah, this is loose. This is just held in by the nasty glue now. Ah, this is so bad. Why did they use this kind of glue here? This is pretty much what happened with all the ones that were glued down to the board. They are just so well attached that the whole capacitor disintegrates basically. This one is also glued to this resistor here. Let's see if this one fits in here at all. I think it could. Yep, fits perfectly. So snap in, perfectly okay for this. And this in fact is also a snap in capacitor. You need 1 centimeter, I believe, pin spacing snap in capacitor for that position. So that's all the electrolytic capacitors replaced. The new ones are all a bit smaller than the old ones, which is just because they are more modern, I believe. And this should, in theory, be a functional power supply again, hopefully. And I think I want to glue these down again, but I'm using a lot less hot glue for future generations, just to have it easier. So I am going to clean the backside of this, and I'm going to tin the traces a bit that I exposed, and then add some UV curable solder mask that I have. Could also use nail polish or some non-conductive lacquer. Nail polish actually is widely used in the hobbyist community, but now we have a relatively inexpensive solder mask that you can just buy, which is UV curable. Just going to give this a good wipe before I do that to remove the flux that I just added to the equation here. And inspect the solder joints a bit more, just to make sure that everything is correct. This is a power supply after all, so you want to be extra careful with that. I'm going to check the polarities, of course, as well. It's just electronics cleaner that I'm using here. I'm just going to let this evaporate a bit and then come back. So these traces here, where I removed some of the corrosion with my fiberglass pan, I'm actually going to remove some more here, I think. I'm going to tin these traces and then seal them off with some UV solder mask. I'm just going to add some solder to that, very thin layer, just to protect the traces a bit more, and then clean off the residue a bit more. Of course, this is, I wouldn't have to do this, but I want to do this properly. That is tinned, and then I'm going to add some solder mask there. From this tube of Xerit X UV curing solder mask ink, which is, yeah, it worked rather well for me in the past. I hope this is still good. I had this lying around for several years now. So I'm just going to smear some on here with a Q-tip. And that is just for extra protection. You don't necessarily have to do this on a hobbyist project like this, but it protects the copper from corroding, and it also helps insulating this electrically, obviously, because this is a power supply, as I said repeatedly, and you want everything to be properly insulated, even if this is not the high voltage side, probably. I'm not sure, it might be the high voltage side still. This is probably the low voltage side, and here's the division. Yeah, so definitely a good idea to put this stuff on there. And then I'm just going to shine this little UV torch on that. And from experience, this takes a while, so I'm just using my third hand, my little helper here, to hold it in place. for I think half an hour or something like that. Should do. And then the UV solder mask should have cured completely. This is, of course, this is cheap stuff. This is not a professional solder mask, but it works rather well in my experience. I'm going to double check all the polarities and then add some hot glue to these here. A bit less than there was. Some strategic depths of hot glue so nothing vibrates too much. That's basically the function of the hot glue. Now for these wires, I think I'm just going to cut them. They have these metal inserts here for soldering them to the circuit board properly. Crimped inserts basically that go through the circuit board and then crimp onto the wires. I'm just going to shorten them to keep that in place basically and solder new wires to them that are a bit longer. And of course add heat shrink tubing because these are the mains wires, so you want to insulate them properly. So these are getting some extensions basically. I salvaged these from, I think, a mains cable of some description. And yeah, I'm going to add heat shrink tubing to these. Going to wrap them around themselves and solder them. And then it should be a relatively good connection. So now I'm going to solder these ends back to our mains input here. And the polarity doesn't matter because I'm in Europe and we don't have polarized outlets. So this can just go either way. And I'm also going to add another bit of heat shrink to put over the contacts there, just for good measure. Yeah, I think we're good. I left the cables a bit longer to make this easier to work on, which shouldn't be any problem. I'm going to cable tie them together, I think. And you want to make sure that these capacitors here are still in place, so we can't slide the heat shrink tubing over that too much, but it's still going to help insulating that. As you can see, there's not an awful lot of room to maneuver here. But these longer cables should make things considerably easier. So it has to go into some clips on this side here. And there are some ground screws, of course. Just going to put the screws back in, I guess. Sorry about the background noise there. That was my hot air station. So yeah, the screws. And there are some that have a little star-shaped washer on them. Those go on the grounding lugs here, which is pretty vital because the whole mains ground is connected to the casing. There are some that have like plain washers. These are the other ones. We need to put the screws for these here back in. We should cable tie that down. And I'm also going to add a cable tie to our new mains connection there. Just cable tying that. Yeah, looks good. I think it can go back together at this point. So this should fit on here. Now, one of the kind of unfortunate issues with these power supplies, or it's not really an issue, but it's an issue in case you repair one of these, is that these only start up if they get some logic signals. The Macintosh has a keyboard power button, basically. So you can power it up with the soft power button, and this needs signals on this connector here to start it up. So we are going to have to put the Mac back together, basically. I am going to do some cleaning on the fan and things like that, in general cleaning of the case. Before I do that, as long as we have this out of the case, there's a lot more room to maneuver. And then we're going to give this a test and cross our fingers collectively. Yeah, I'm going to clean this, the fan in particular, because that's super dusty, as you can maybe see. Just using a brush and a regular vacuum cleaner, and then I'm going to clean up the case parts a bit and some of the dust that I can see here. There's not that much dust except for where the fan is. So the fan is significantly cleaner, and as we've seen, we can put this whole thing to the side and then get this here in here in some way or the other. There we go. That's just a matter of getting that over there. Okay, the bezel is back in position, I believe. And there's the one screw that holds the whole power supply construction in place. That's down there. Also a ground connection with a star-shaped washer, I believe. So that should be tight. These are all keyed to one direction they go in, I think. So there's nothing much that can go wrong there, thankfully. This snaps in here and sits like so. Okay, and this has a little metal hook here on the casing, and this sits in. So that should be our power supply back in place. This cable slides in here. Let's see if this thing fires up. I'm going to connect a keyboard, which I thankfully got, and yeah, we're going to see if we have a working system or not. And I'm also going to hook it up to my monitor here, because I have a VGA cable that hopefully works with this TV monitor. And of course, there's one thing I forgot, and that is to put the main board back in. It's not going to do much without a main board. And it's not going to power up because, as I said, that's soft power. And yeah, we need a keyboard to power it. So this slides, there are two plastic slides basically. This sits on. And then it plugs into the connector on the back side here and connects to all the internal peripherals, basically. Now we have connectors for keyboard, mouse, and other things. So, quite a bit of anxiety at the moment, because I want this thing to work, but I'm not sure if the power supply is going to work. So, yeah. We're going to find out shortly, I suppose. The first thing is going to be plug in the mains, because as I said, this is a soft power on, and it might very well be that this just blows up right away. We're going to see, and hopefully I'm going to get a good angle. I'm going to zoom in on the power supply. In case it blows up, at least it makes for good video. So, here goes. Contact. Okay, no explosions so far. I guess that's a good sign. This machine should now be powered. At least the standby power should be in there. Let's see if we can power the whole system on via the keyboard. Oh god, I'm so nervous. I've honestly not been nervous like this in quite a long time. Nothing much to lose, I suppose. We should be able to push this button and the system should power on, in theory, if everything went according to plan. 3, 2, 1, go! It chimes. It chimes. I heard it chime. And we get a picture. Okay, we get a mouse pointer. That's about as far as we got last time. The fan doesn't spin at all. And we don't get a boot disk. But at least the power supply seems to somewhat work. I'm not sure. I think the fan is temperature controlled actually, so it might spin after a while. This looks really promising, except for the hard disk drive not spinning up at all and basically nothing working. But at least we get a picture and it chimed. It started up, so we somewhat have the correct voltages. Probably. Also, no explosions yet. I'm a bit worried about the fan not spinning up there. But yeah, the hard disk doesn't spin up either. So I guess what I'm going to do is to power this down again. Processor and things like that seem to work. Don't feel any excessive heat at this point. But our fan is not working at all. I'm just going to unplug this again. I think that's probably a reasonable thing to do. So we are going to have to do some work on this, I guess. And there's some hum. Maybe you can hear that in the background, but that's from the TV. That needs a recapping, actually. I might have a bootable floppy disk somewhere as well, so maybe we're going to try that. But the disk drives and things like that didn't do anything so far. I'm not sure if I left a connector out or if there's something wrong with the connections on the board there. So here's the hard disk. So it is connected, there's a hard disk in there. Let's start this up again and see if the disks are accessed or anything like that. It would definitely be nice if we were able to fully boot this up. There's our original Macintosh Performa 630 CD. That should be a bootable CD, I think. And I also have Mac OS 8 and all the drivers for the DOS card that were thankfully still there. Definitely boots up the mainboard and things like that. I don't hear any hard disk spin up or anything like that. And the fan still doesn't work. Yeah, we might have some kind of problem here with the 12 volts. The 12 volts being used for mostly the motors in the disk drive and the hard disk and the CD-ROM, I believe, as well. Should say here somewhere. 5 volts and 12 volts. Yeah, the old school CD-ROM and disk drives had 5 volts and 12 volts. And some newer disk drives only use 5 volts. But don't get any reaction here, so something's wrong there. Maybe we just don't have 12 volts. It's a 12 volt fan as well. Maybe the 12 volt rail is gone. I think the rest of it, just what we can see now, should work on 5 volts alone, basically. There's no 12 volts needed for that. Let's measure some voltages. Nothing much to lose, as I said. Let's see, on the fan connector here is probably the easiest way to do it. There's no voltage there at all. So I'm just measuring the voltages on the hard disk connector here, the hard disk power connector, and this is the 5 volts, the red wire and the black wire. The black wire is ground and the red wire is 5 volts. It's still, I think, the color coding. And we should have 12 volts on the yellow wire. We have 0.8, so something's wrong with the 12 volts. Maybe we're going to have to take apart the power supply some more. Let's see if we get 12 volts on the power supply itself. Don't think I can measure in there. I'm not sure. Yeah, no, that's the same. We don't have any 12 volts from the power supply. We do have 5 volts though. That's pretty evident that we got 5 volts somewhere. That's our 5 volts, 5.15. That's nice and healthy, but we don't get 12 volts. That's why the fan is not spinning, and I don't think I want to keep this running for any extended period of time without the fan running at all. So we do have a serious problem with the power supply. I maybe should have checked that beforehand, but I thought it would be a good idea to replace all the capacitors before, which definitely was a good idea. Not regretting that. Yeah, there's going to be more tinkering with this machine, unfortunately. Or maybe fortunately, if you enjoy this kind of troubleshooting. Yeah, that's kind of the second worst outcome, I guess. The worst outcome would, of course, have been if the power supply just blew up instantly, which it didn't, so I did something right there. But we don't have 12 volts coming from the power supply. Not sure if that is controlled by some logic or something like that, and that just doesn't get the signal to power on. I'm going to have to read up on that. I'm not sure how these things work, but probably it should output 12 volts right the moment you power it on, basically, which would be normal behavior like from a PC power supply or something like that. Maybe I'm going to go the route to put a PC power supply in this and make a little adapter board for the logic signals powering this power supply on, or telling it to power on, and adapting that to a PC power supply, which is entirely possible. It's just a bit of a hack job. And as I said, you need to use the original casing here because basically the whole computer is built around that and clips into it, and the mainboard slides into the plastic slides that are attached to this cage here where the power supply is. Kind of unfortunate that we don't get 12 volt out of this. We could potentially just build a secondary 12 volt power supply and power things from that probably, but that would be even more of a hack job, so I'm probably going to take a look at the power supply some more. And maybe we find something. It might just be a 12 volt regulator. I don't know if the 12 volts rail is switched. Probably it is. Yeah, I guess unfortunately that's all I can show you today. At least we've seen this startup. It chimed nicely and cleanly. And yeah, the main board seems to still work. That's a good sign after I recapped this. The PC card seems to at least let the signals from the 68040 processor through. That is a very good sign. No errors except for no boot device, which is kind of to be expected if you don't have the power for the hard disk motors or any media motors basically. So that is expected behavior if you don't have the hard disk spinning up at all or any of the other peripherals here. I guess that's it for today. Unfortunately. And I'm not sure what I should do. I think the cleanest way would be to just replace this power supply altogether and put a modern, more modern power supply in there and try to fit that. But that's going to take some major metal working, and we all know that I'm not the best at that stuff. But yeah, we're going to see. There's going to be more videos in this series, and it is going to be a very thorough, long-term project, as I said. Maybe there's going to be a couple of videos in between, as usual, because I need some time to A, think about this, and B, get the parts the moment I made up my mind. That's how it goes sometimes. More work needed, but at least the power's on. Power supply didn't blow up, so kind of a success. Partial victory. So that's it for today. Thanks for watching. Thanks to everybody who supports me on Patreon or on the channel memberships page on YouTube or on Ko-fi or elsewhere. The links are in the video description in case you want to give me some support, which would of course be highly appreciated. Thanks for your thumbs, your comments and all the other things that I'm supposed to say. I'm not going to say all of them. Thanks for watching. I'm Jan Beta. See you next time. Bye.